so this is subset and set operations. First thing we're going to learn is we call this A prime or A complement. It basically means not A. So whatever A is, if we have A prime, we're going to say, or A complement, we're going to say whatever A contains, we're going to do the opposite. So it says let U. U means a universal subset. U is universal. And so universal means like, just think about every single component inside the box. So it covers all elements inside the box. So from here I have this whole set as U. And then I have A that is going to be 3, 4, 10, and 16. So it's part of U. And then you have B, which has 2, 3, 4, 9, 10, 16, 19, and 20, which is part of U as well. And it also has some of the same elements as A. So when it says find the set A prime, this is going to be U minus A. So the universal set minus A. So whatever the universal set is going to be 2, 3, 4, 9, 10, 16, 19, 20. And we're going to take out A. So when we take out A, we're taking out 3, 4, 10, and 16. So that means that A complement is whatever's left over. So it's 2, 9, 19, and 20. That's going to be the solution, A complement. So whatever A was, we took it out of the universal set. So then this one says find set B. It's the same thing. Whatever B is, we're going to take out of the universal set. So it's the universal set minus B. And so I'm looking at the list. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. These are the exact same elements found in each set. So U minus B is going to be what we call B prime, or B complement is going to be the empty set. It's empty because it's 1 for 1 here. So 2, 3, 4, 9, 10, 16, 19, and 20. So instead of saying 0, we say it's the empty set. And then this one says find the complement of the empty set. This is going to be the opposite of nothing, which is going to be everything. And remember, between the universal set, the A, and the B, you have to think about which set automatically encompasses all. That's always going to be the universal set. So this is going to be the full set, or the universal set. All subsets of the set separate multiple subset with commas. So a subset is going to have, again, these brackets, right? All sets or subsets are going to have those brackets. So here's a reminder of some of the symbols. You have like a curved E, that's the element. Subset is a curved C with a line underneath it. A proper subset is going to be a curved C. I also like to call this contained, because a proper subset does not contain the original subset, or the original set the way subset does. So we're going to create subsets first. And so the formula is going to be that we need to determine how many elements are in our given set. So there's 2. So then we're going to say there's 2 elements, and then we want to say 2 raised to the amount of elements is going to tell us the number of subsets. And so when we put them together, it's going to be the empty set, empty set X, set Y, and then set XY. And then we put all of those again as the subset. Different from the proper set. The proper set will not include the original set. So this is otherwise saying that this is the empty set. Another way of writing it for today. Okay, so 4A is asking if Arkansas is an element of this roster, of this set, and that's true. And then 4B is asking if Arkansas is a subset of this roster. So that would be false because it does not have the set notation. So that's going to be false. And then it's asking if Oklahoma is an element, or the set Oklahoma is an element of this set, and that's going to be false as well. And the reason why it's false is because elements don't have that set notation around. So then the next one is asking if the set Oklahoma is a subset of this set, and that's going to be true because it has the subset notation. And then E is asking if the empty set is an element of this set. So in this case, it's going to be no. It is a subset. So now it's asking if empty set is a subset or a proper subset. This is, the C means proper subset or contained. And that's going to be true.